So here it has been asked that if L1, M1, N1 and L2, M2, N2 are the direction cosines of two mutually perpendicular straight lines, then show that the direction cosines of the line that is perpendicular to both these are given by this. So then here, so here it is given that L1, M1, N1 and L2, M2, N2 are the direction cosines of two mutually perpendicular lines. So we can say that L1, L2 plus M1, M2 plus N1, N2, that should be equal to 0. So now, and also the sum of the squares of the direction cosine should be equal to 1. So it means L1 square plus L2 square, L L1 square plus M1 square plus N1 square, that is equal to 1. And also L2 square plus M2 square plus N2 square, that is also equal to 1. Now therefore the uh, therefore let the direction cosines of the line that is perpendicular to both these L1 and L2, both the L1 and L2. So let's say the direction cosines of this L1, that is L1 M1 N1, and for L the straight line L2, that is L2 M2 N2. So the direction cosines of the line that is perpendicular to both L1 and L2 be, suppose L, M and N, suppose. So then obviously therefore we can tell that L into L1 plus M into M1 plus N into N1, that should be 0. And obviously L into L2 plus M into M2 plus N into N2, that should be equal to 0. Then from here we can solve, and then we can tell that L1, L2. So now so actually there is a rule that if we have two linear equations in x, y and z, suppose if you have one that is a1x plus b1y plus c1z, that is equal to 0, suppose, and we have suppose a2x plus b2y plus c2z, that is equal to 0. Suppose we have these two linear equations, then we can tell that x divided by b2c1 minus b1c2, that is equal to y divided by um, y divided by c1a2, or I can tell y divided by a2c1, or I can tell, yeah, c1a2, sorry. Hence there is a rule for cross multiplication rule. We have called cross multiplication rule, that is, suppose we have these two e- e- equations, then the coefficients of x, y and z we can write. So for x the coefficients are a1, a2, for y the coefficients are b1, b2, and for z the coefficients are c1, c2. Then we can write it as that x by b1c2 minus b2c1, that is equal to y divided by c1a2 minus c2a1, c1a2 minus c2a1, that is equal to z by a1b2 minus a2b1. Okay, so here so if we apply this rule if we apply in these two equations, then therefore we can say that L divided by the coefficients of L, M, means L, M, and N. For L, M, and N, the coefficients in these two equations are obviously L1, L2, then this is M1, M2, and this is N1, N2. So we can tell L by M1, N2 minus M2, N1. So here we can see that it is X by B1, C2 minus B2, C1, that is equal to Y by C1, A2 minus C2, A1, and Z, and that is equal to Z by A1, B2 minus A2, B1. So this is the cross multiplication rule. So this will be L by M1, N2, M1, N2 minus M2, N1, and that is equal to M by, here again I have to write this is L1, L2. So this will be N1, L2, N1, L2 minus N2, L1, that is equal to N by L1, M2 minus L2, M1. So suppose we take this M1, N2 minus M2, N1. That is equal to P, suppose, and N1, L2 minus N2, L1, that is suppose equal to Q. And suppose we take L1, M2 minus L2, M1, that is equal to Q, R, suppose. Then, therefore, we can write this as L by P, that is equal to M by Q, that is equal to N by R. And we know that um, if we have like A by B equal to C by D, that is equal to E by F, suppose, then that will be also equal to A. That can be also written in this way, which is A power N plus C power N plus E power N whole power 1 by N divided by B power N plus C power N plus F power N divided by whole power 1 by N. So these ratios will be equal to this ratio also. We can prove this. Okay. So therefore, if we apply in this case, so L by P equals to M by Q, that is equal to N by R, then that will be also equal to, so here if we take N equal to 2, suppose, if we take N equal to 2, then this we can also write it as it will be A square plus C square plus E square whole power 1 by 2. It means it is square root of that divided by square root of obviously B square plus C square plus F square, that we can write if we take N equal to 2 here. So this will be also equal to, this will be L square plus M square plus N square whole power half. So it is square root of that divided by square root of, this is P square plus Q square plus R square. So now L square plus M square plus N square, its sum is obviously 1. So it is 1 by square root of P square plus Q square plus R square. So now this value of square root of P square plus Q square plus R square, that is what? That is obviously square root of your P is m1 n2 minus m2 n1 whole square, plus this is n1 L2 minus n2 L1 whole square, plus it is, yeah, this is L1 m2 minus L2 m1 whole square, square root of this thing. So now that will be equal to, we can prove that is also equal to square root of, this will be L1 square plus m1 square plus n1 square into L2 square plus m2 square plus n2 square minus it is L1 L2 plus m1 n2 m2 plus n1 n2 whole square. We can prove this, that this is equal to this. So it means we know that this we have proved it as 1, and this is also equal to 1, and this is given as 0. So this will be equal to root over 1, which is 1. So therefore this is equal to 1 by 1, which is 1 only. So therefore square root of p square plus q square plus r square is 1. Therefore we can tell L by p equal to 1. Therefore L is equal to p, which is equal to square, which is equal to m1 n2 minus m2 n1. And then similarly m by q, that is also equal to 1. So therefore m is equal to q, which is equal to n1 L2 minus n2 L1. And this n by r, that is also equal to 1. So therefore n will be equal to r, which is L1 m2 minus L2 m1. So therefore n is this, m is this, and p is this. Therefore here p, q, and r are the direction cosines of the line L3. Therefore I can tell that m1 n2 minus m2 n1 and n1 L2 minus n2 L1 and this L1 m2 minus L2 m1 are the required direction cosines, of the normal of the uh, are the direction cosines of the line that is perpendicular to both the given straight lines, are the direction cosines of the line that is perpendicular to both the given lines, hence proved. So thank you.